Hello everyone. This is a video on factoring special cases, your difference of squares, and perfect square trinomials. Now, this first example right here and this one down here are both perfect square trinomials, or excuse me, difference of squares. The first term is a perfect square, the second term is a perfect square, and there's a subtraction between them, or a negative perfect square constant. So the way these factor are always the square root of the first term plus the square root of the second term and minus the square root of the second term. And if you were to multiply these back out, you realize that you would get positive 5x, negative 5x, which would drop out. And notice that one of them's positive, the other's negative, so that will give you the negative second term. If you have the same signs here, you're going to wind up with a trinomial, and this one is a perfect square trinomial right here. And if you look back at the video where I talk about squaring binomials, you'll notice that there's a pattern going on. Not only is the second term, or excuse me, the last term and the first term are both perfect squares, and that's what you use inside of these binomial factors, but you'll notice that the middle term in your original trinomial is double the product of your first and second term in your binomial factors. So the other way to write this answer is x minus 5 squared. Okay, now down here is a couple of quick examples. You may want to pause and see if you can do these correctly. Okay, so I'll give you a moment. All right, and hopefully you're back and you tried this. The square root of, or what is being squared here, is 3x. What's being squared here is 5. So one of them is going to be subtraction and the other is going to be plus, or addition, positive. It doesn't matter the order. When you distribute these, notice you'll get a negative 15x and a positive 15x for your middle terms, which will drop out. However, notice that there's a plus here. Well, just like there was a plus right there and a subtraction, if this was addition right here, we would have adding on both of them, but since it's subtraction, both of them are identical. Okay, they have exactly the same sign, or 3x minus 5 squared. Now, one of the things we're going to learn in college algebra is, just as a side note here, one of the things we'll talk about when we get to the material for test 2 is that actually everything is factorable. We're going to start including the complex numbers, and if we look at this, which is usually prime over just the real numbers, but take a look at how this factors. You don't have to know this yet, but I'm just kind of giving you a preview here. 5i and x plus 5i. Okay, so if you think about that, 5i times 5i is going to be a negative 25i squared. And remember, from the complex numbers, a negative 25i squared, I squared is negative 1. So that's going to switch that back to a positive 25. So these sums are actually, sum of squares, perfect squares, are actually factorable if you include the complex numbers. And that's what we're going to be learning on one of the chapters this semester.